Hi, here's your starter. Okay, so pause the video and let's have a little go at this starter. It's already gone wrong. Okay, so I hope you're okay, and here's your starter. Pause it. Right, so this is not in the form that we want, so the first thing I'm actually going to do is multiply all through by x. I think I'm going to multiply through by x. So 2yx equals x plus 1 dy dx. And now I'm going to rearrange this. And when I rearrange this, I'm going to take this dy dx over to the other side, and I'm going to have x squared minus 1 lots of dy dx plus 2yx equals x. Now we need this dy dx to be on its own, so I'm going to divide all through by x squared minus 1. And then I'm going to get my integrating factor, which is e to the integral of this function. And you can see that that's in the form where the derivative of the denominator is the numerator. So that's going to be e to the ln x squared minus 1. Whoa. Okay, which is x squared minus 1. I'm struggling a bit with that x squared there. It looks a little bit like a z. Bear with me. I'm now going to multiply all through by x squared minus 1 dy dx plus, when I multiply this by x squared minus 1, look at this, it's lush. Okay, how this comes out, and if I multiply this by x squared minus 1, I've got that. So I can see that I differentiated x squared minus 1 times y. Okay, on that left-hand side. Let's integrate both sides with respect to x. So I'm going to get x squared minus 1 times y equals the integral of x dx. So what have I got? I'm going to have y is 1 over x squared minus 1 integral of x dx. Y and of course you can simplify that if you want to. Right, I'll show you what we're looking at today. We are looking at homogenous Okay, now remember, homogeneous means every term involves the dependent variable, which in most cases is y, the one on the top. Homogeneous second order differential equations. Okay, with constant coefficients. Okay, right. So the form that these are going to take, these differential equations are going to take, look like this. Obviously A, B and C are going to be our constants. So your second order, that's a B by the way, plus C, Y. So you can see every term involves the dependent variable, hence the homogeneous. Now, to be able to solve this, we are going to create something called an auxiliary equation. And an auxiliary equation is just like the helper. It's what's going to help. It's like its partner. And we use lambda for this. So the auxiliary equation for this, is literally A lambda squared plus B lambda plus C equals 0. And we're going to solve this. Okay, so these are what we need. Now, to solve these equations, okay, so we have the solution. Okay, first of all, we've got the solution to the auxiliary equation. And then, whoa, that's really bad, sorry. And here we have your general solution to the differential equation. So this is obviously what we want. Now, if we go back, you can see your auxiliary equation is a quadratic. And when we're solving a quadratic, we can only have 3 case scenarios, can't we? We can have 2 distinct roots. Okay, that's not come across very well, has it? So our first case is 2 distinct roots. And they'll be real roots. And we're going to call them lambda 1 and lambda 2. And you would learn these. We expect you to learn these. So your general solution would take this form. Y equals A e to the lambda 1x plus B e lambda 2x. Okay, that's your first case. The second is where you have 1 repeated root, okay? 1 repeated root. And that would be called lambda. And the general solution that you would learn that goes with this is A plus bx e to the lambda x. And then the third situation that you would have is where you have complex roots. And of course, you will have 2 complex roots. Complex roots, well, they come in pairs, don't they? And they will be in the form alpha plus or minus I beta. And in this instance, your general solution will be e to the alpha x bracket a sine beta x plus b cos beta x. They would be learnt, okay? Now you don't have to learn them, you're just going to have them in front of you on a bit of paper. So, moving on, here's example 1. I want the general solution to d2y over dx squared minus 7 dy dx plus 10y equals 0. So this is what I do. I make the auxiliary equation and I solve it. So this obviously factorizes, doesn't it, very easily. And I'm going to get my 2 solutions, 2 and 5. I then literally, in an exam, you've learned this, but you're literally going to give the general solution to the 2 real. So it's 2x and b e to the 5x. That is it. Okay? Second example. Number 2. We want the gen solution and this time it's 2 d2y dx squared minus 4 dy dx plus 5y equals 0. So again, the first thing that I do is I create the auxiliary equation. Now you'll find that that doesn't have real roots, it has two complex roots, and the roots are going to be 2 plus I and 2 minus I. Okay, alpha is 2 and beta is 1. So you go to your general solution for complex roots, it's e to the 2x, a sine 1x plus b cos 1x. That's it. And next one, number 3, we're going to find the general solution to, given in a different form here, that's a y dash by the way, sorry, that's not gone very well, plus 4 equals 0. So that's just another way of writing a second derivative. So the auxiliary equation you can see you've got one root, it's lambda. So you literally read off your general solution that you have learnt and you replace your lambda with 2. For a particular solution, so example 4, we're going to solve d2y over dx squared minus 3 dy dx plus 2y equals 0, given that y equals 1 when dy dx equals 0 and when x equals 0. So the first thing I'm going to do is I'm going to get my auxiliary equation. It's got two real roots. The roots lambda 1 is 1 and lambda 2 is 2. I go to my general solution for when I have two real roots, and I've got a to the e 1x plus b to the e 2x. But I want to find my values of a and b. So the first thing I'm going to do is I know that y is 1 when x equals 0. So I've got 1 is a e to the 0 plus b e to the 0. Okay? I now want to find dy dx, which is a e to the x and 2b e to the 2x. And I know that this is 0 when x is 1. I don't mean that. This is 0 when x is 0. Sorry about that. So 0 equals a e to the 0 plus 2b e to the 0. Okay, that's very badly written. That's a 2x, isn't it? So I'm going to rub that out, okay? So I've got simultaneous equations. 0 equals a plus 2b. Put them in your calculator. B is minus 1. A is 2. And all that's going to happen is they go back in your general solution. So you've got y is 2 e to the x minus 1 e to the 2x.